I'll be honest, I kind of forgot about React Forget. It's silly to say that, but it kind of disappeared. It was announced all the way back in 2021 as part of ReactConf, and I've only heard about it once or twice since. In fact, the dev that was leading the project originally has since left Meta. This had me pretty scared that React Forget might have truly been forgotten. Thankfully, it hasn't been. And some of the stuff I've seen recently has me really excited. Specifically, this tweet from Sebastian that spotted it on Instagram. Yes, the React team is actually using Forget in production now. This single fact makes me so excited about Forget again. Because I don't have any inside info for once, I'm actually going to do a little more speculation than usual. And we're going to try to dig into how React Forget's being used and what a future looks like where we don't have to memorize everything ourselves. Without further ado, let's see what we've discovered and what exists, because all we have are a few conference talks. Let's dive in. First, I think it's important that we build some context from the original presentation. Once again, this was in December of 2021, over 2 years ago, but it's very important context that I want to make sure we don't forget the original promise of React without Memo. If you want to watch the whole video, I'll make sure it's linked in the description. We're just going to skim through the important bits. Looks reasonable. Juan, hopefully I'm pronouncing his name correctly. Phenomenal developer. Really sad that he's no longer working on React Forget because he clearly knew what he was talking about with this project. It does seem to be in good hands though, so.
Hey, what's up folks? I'm Xuan. I'm a software engineer at Meta. So today, I want to talk about React and memoization. Here, I have yet another to-do list. As JavaScript developers, we just really love to-do lists.
Who here loves to-do lists? I want to see some ones in chat. Who here has built a to-do list to demo something? Ones in chat if you built a to-do list to demo something before. This everyone's go-to? Yeah. I feel like for every developer, there's at least 2 to-do list apps.
So we enjoy the simplicity of the React code here. Until we will open up the dev tools and we realize whenever we add a to-do or toggle a to-do, all the other to-dos are actually getting re-rendered as well.
This is the thing most people complain about with React, in case you're not already familiar. Because React aggressively re-renders things whenever a parent node changes anything, you end up with re-rendering occurring on a lot of things. So in this case, when you add a new to-do, all of the other to-dos are getting re-rendered. And even when you toggle one, they're all getting re-rendered. They're not reappearing on the DOM. It's not recreating the node on the DOM, but the virtual DOM, which binds things between the React world and the real world in your browser, that has to validate at every step, hey, did these things change? And if you want to opt out of that, that's a thing you have to do manually through processes like memoization. I'm going to skip a little bit. Again, I highly recommend watching this whole video if you haven't already. It's incredible. It's a great 12-minute watch. What we see here is a more complex example where you also have a color picker where you can pick a color in the same window. And whenever you drag your mouse around this, it causes everything to re-render. If you don't want that to happen, if you want those elements to stay static, I'll play it a bit.
Feels much more snappy. 200 times is and can pick a color to theme the user interface. If we try this code out, it works, but the app feels pretty laggy and slow.
See that lag?
When we're picking color. And the reason is that changing theme color will re-render the blazing to-do list and to-do list, which will eventually call a getFilter function again and again. If we pay attention to the zoomed in number here, it's been executed about 200 times.
Yeah. So what you do instead is you throw get filtered into a memo so you don't have to recall this specific function over and over again just because something else changed. As long as to-dos and visibility haven't changed, your filtered elements are going to stay the same.
To fix this, we can wrap the getFilter call with the again. So this is the user experience we want.
Yep. It shows that this get filtered gets called way less, but it still has to re-render all of these elements. And if we skim it a little bit further, this is where things start to get chaotic with React. Even with this relatively simple example, the relationship between all of these things, and I love how the arrows are used here to show it. Once you're doing all of this memoization, the very top to bottom readable nature of React code gets a little bit lost. And I feel like that sucks. It's one of the things that makes React code painful. And this is when you stop losing a lot of the value of React when you run into these crazy memoization cases. There are ways to architect things where it's not as bad, like memoizing at different levels and such, but it does kind of suck. And it makes the control flow of your React components way more complex. It'd be really nice if you could write your React components in the simple linear way way that the first example was written without having the performance issues that are inherent to that style of writing. And this is the compromise that they're talking about here, where if you don't use Memo, the developer experience is great, but you're going to start running into lag. That my face is covering the word UX in the corner there. So if you were curious, the DX is great without Memo, but once you're optimizing all the time, it gets a little more painful. And then UX quickly can get slow if you're not optimizing, but the user experience way better if you do. I'm trying to remember what this part was.
This ergonomics versus performance issue is just so intrinsic to the model of React and doesn't look like we can optimize. Maybe we should use template rather than JSX, but we just really like the expressivity of JSX. Or maybe we should go back to class or start with mutating stuff so it's easier to track. What we think is that something that has been missing here. Today, I want to give you a sneak peek of some research that we've been doing that we think could solve this problem for the future of React. To talk about this, we need to rethink how we do memorization.
Like he says, for the future, when he said for the future of React, he meant it. When he said for the future of React here, he meant it because this took over 2 years for us to even start seeing it in the wild, much less have access to it.
And look at this code again without the memorization hook.
Oh, it's so pretty. Why can't code always be this simple?
The end of the day, the to-do list is just a function that takes inputs from props and states and generate outputs such as UI and effects. And the need to create an intermediate value such as filtered and handle change to do that. To help with understanding, we can also visualize the dependency graph.
This way of visualizing what variables affect what things in the chain of dependencies here is such a good visualization. And ideally, your code should be as simple as this, but once you have complex back and forths, things get a lot more complex. Skipping a little bit, again, watch the whole video if you want to better understand the depth of this stuff. The core point here that I want to focus in on is the use of these magic variables that get updated using this memo cache. The goal here is to automatically, via a compiler, wrap any code that could take time to execute and only execute it when its dependencies update. It's kind of like signals such as what we see in Solid and recently in Angular, but it's happening at a compiler level. So the code you write is still very simple and procedural, but the output is really performant and well optimized. And the magic piece here is this memo cache where every value where it's defined gets a key in your cache and falls back on that when none of the dependent values have changed. This can get even more complex once you have sub-elements and children that do or don't need to be re-rendered. And this lets you avoid memoizing components entirely by breaking out those children and referencing them from the memo cache if things haven't changed, and also updating the cache if they have. This lets you skip a lot of steps and just return an existing result instead of having to recreate that result every time something changes. This is really exciting stuff, but where has it gone since? Why haven't we heard about this for 2 years? Well, we just recently have. This is from React Advanced London. Awesome that our good friend Jack Harrington was the one who streamed this, which is dope.
All right, so I'm Joe. I'm an engineer on the React team at Meta. And in this talk, we'd like to share our vision for client-side React development. Specifically, I'm talking about React Forget. Forget is a compiler that we've built at Meta that automatically memoizes your components and hooks. So if you were hoping for us to be open sourcing Forget today, I am sorry to disappoint you, but we've made a lot of progress and we're excited to share more about that with you today. So I'm going to be talking about what our vision is, what Forget is, and how it fits into that vision. And then Mofe is going to come up and talk about our progress shipping Forget at Meta. So to understand our vision for React, it helps to look at some code. Here I'm showing a simplified version of an internal component from Meta. This component takes a heading, a list of videos, and a filter, and then it renders the heading and list of videos that match that filter. You can imagine the real component is more complicated. The filters actually state, etc. But it's kind of a simplified version. So personally, I think there's a lot to like about this code. It's a small, clear, concise component. It uses plain JavaScript values, arrays. We use standard JavaScript syntax, if-else for conditionals, a for loop for iteration.
No if else. We're a fan of that. It's just an if with an early return. If else isn't great. Just standard if statements. A+.
Right? We don't need to learn something new. This is just the JavaScript that we already know. Use the platform. So in a lot of ways, this is React at its best. UI as a simple function of data. There's really only one potential problem with this code. If we were to ship this as is, we might see that parts of our app re-render unnecessarily, and that can affect performance, slowing things down. So let's see an example of how that can happen. Imagine that our component re-renders, but only the heading has actually changed. When the component re-renders, it passes that new heading down to the heading component, which updates as we'd expect.
My cat is screaming so much that I'm like getting a headache from it. So I know you guys can't hear him, but it is stressing me out. I will be back in less than 2 minutes. I am so sorry. I will let the video keep playing so you have something to watch while I am gone.
But that's not all that happens by default. When our component re-renders, the entire component reruns. This entire function reruns. That means we create a new filtered videos list, and then we pass that to video list, which then also re-renders all the way down the tree. And this will happen all the way down the tree, even though nothing meaningfully changed about the videos. To address this, we can use two React APIs, useMemo and React.memo. So here, I've applied useMemo to the logic for filtering the videos. The array at the bottom here tells React to only recompute filtered videos if the videos or filter values have actually changed. So now, if only the heading changes, we don't recompute the list of filtered videos. Great. But that's not quite enough. Because even though we're passing the same filtered videos down to the video list component, by default, React will still re-render a component, even if its props
Hopefully I
haven't
didn't miss
changed.
anything important.
To opt out of that, we wrap the component with React.memo. So now we get the expected performance. With these two changes, now when heading changes, we won't have to update the video list component. Great. And if you judiciously apply React useMemo, use callback, which is for kind of the callback version of useMemo, and then React.memo, if you use them consistently throughout your code base, you can achieve really good performance with React. And a lot of other presenters have talked about that earlier. We found that generally when applications do have a performance problem, it's because of this kind of missing memoization, and it can be fixed by just adding this back. But this memoization has made our original code a lot less concise and clear.
I probably should have called this out a few places by now, but I want to really emphasize this point. There are not many projects the size of React that will just come out and say something this bold, where they have a solution to the problem, but it's not a good enough developer experience, so they're going to put years of work into working around it. This is a bold statement, and I wish we saw more of this from developers. I think Svelte, for example, does a really good job of this too. Rich Harris has come out and said outright that the way they did state in Svelte was not good enough for large applications in complex state management. And as such, they rethought state from scratch as a more hybrid signals-based approach in order to make scalable state management in Svelte possible. And I love when big projects are down to be this type of honest and say, yeah, our solution just wasn't good enough yet.
We're no longer simply describing what the UI should be showing. We're having to tell React how to process our code. That's kind of losing some of the original idea of React, right, declarative rendering, but now we're having to go into the how. And then our code reviews become about whether we've memoized correctly, whether we memoized too little, too much. We get blog posts arguing that you should memorize everything, blog posts saying that you shouldn't memorize at all, you don't need memoization. And the thing is that both of them are kind of right, because it all depends on the context. This code, the original code here, might be fine in a lot of apps, but for other apps, they might run into a performance problem. But really, with this memoization, our code gets cluttered up with extra logic. We're not just focusing on the core product experience, we're focused on, again, how to achieve it. It makes our code harder to read and harder to change. So in a sense, useMemo is a compromise. We sacrifice some of the clean, concise, original logic in exchange for better performance. But why do we need to make this compromise at all? Well, let's go back to the code. The reason we started down this whole path was that we needed to use useMemo to tell React that the video list doesn't depend upon heading. But we're all developers, we know JavaScript. right? We've already told React that video list doesn't depend upon the heading. In fact, we've used a very well-specified format of instructions that computers already understand to tell React that information. It's called JavaScript. You already know it.
I love that. I was wondering what he was going to say there, because there's a lot of things that specify this. But because video list isn't a child of heading, video list is not dependent on heading. Like, it's obvious to us, but the compiler doesn't know that. And as such, when one changes, it has to re-render both. And that's like a pretty obvious design flaw that has allowed us to write React as efficiently as we have and made it such a simple paradigm. But it also causes these types of problems that React Forget's hoping to solve.
So why do we have to tell React again? Why do we have to also add in our use memo to tell React, oh, this doesn't depend upon these values? What if React could figure that out automatically? And better yet, what if React could figure this out at build time when you compile your app and you didn't need to pay a runtime cost?
This is a recurring theme I've noticed with recent React and Meta JavaScript tools. Both StyleX and React Forget have leaned heavily into this idea of build steps to prevent user experience regressions. Even server components and server actions, some amount, are using build steps to create better user experiences. Really cool stuff. And I like the idea of using compilers and build steps to make better outputs. For a while, React avoided this because React is just JavaScript. And while I do think it's important in the sense that the code you're writing is just JavaScript, this also comes at a cost. That cost is that these more complex behaviors and finding solutions to these performance issues is difficult. And they're trying to find a balance here where it is still JavaScript. And more importantly, you can still import any existing JavaScript code or JavaScript library and it behaves as expected, but React can compile a better path out of it. It's a really interesting idea.
Rather than do some fancy dynamic tracking of values at runtime, we could just figure this out ahead of time and avoid the runtime overhead. So that's the goal of React Forget. It's the code name for this compiler that we built at Meta to automatically memoize React hooks and components. This lets developers write code without needing to manually memoize while achieving the same performance as a well-memoized app, and in some cases, even faster. So to make that really concrete, React Forget lets you write the original code I started with no memoization, while getting performance at least as good as the manually memoized version here.
Moving this so you can see again, the manually memoized version is exporting the default React.memo wrapper of video list.
So Forget really helps in two ways. It simplifies the developer experience because developers don't need to think about memoization. And it helps ensure that we're achieving optimal performance by default. So let's take a look. Let's see. Will the swiping actually work? All right. Hey,
Showing
there
your
it
demo,
is.
nice.
Okay. Oh wait, hang on. I forgot. I got to grab the code. Let's grab that code. Where was it? It's here somewhere. All right, I'm gonna exit out. Let me grab the code. Got to make sure we get the right code.
It's actually grabbing the code from the slide. That's great.
Over here. So what I'm showing you here is our internal compiler playground. I got some example code in there. I'll swap that out. For anyone who's really curious about Forget, you might want to look at that code, but we'll look at this code. Nope, I messed up.
I might want to go back and dig into that in a bit.
Live demos, gotta love it. All right, there we go. So this is our internal compiler playground. This is meant for us to use when we're developing the compiler. You don't need to understand, this is a tool for us, not for the typical React developer. I'm just showing it here just as a way to demonstrate the compiler. So again, I pasted in the original code we started with, right? And so this this is the input, and then this JS panel over here is showing the output from the compiler. So let me zoom in a little bit to make sure y'all can read that. All right.
I like the $sign is use memo cache. I'm sure that's not going to have conflicts in any code base.
The output from the compiler. So let me zoom in a little bit to make sure y'all can read that. All right. That's probably good enough. All right. Okay, let me scroll. Sorry, it's hard for me to see exactly what you can see. All right. Yeah, all right. Okay, cool. So now remember, there was no memoization here, but Forget has figured out that it should memoize filtered videos. This block is equivalent to a use memo. So I'll highlight all this section here is all about memoizing filtered videos. So what does it do? So first, it checks to see if videos or filter have changed. Forget figured out the dependencies automatically for this value. And then it takes the code that we wrote and just moves it inside. Right? It's not reformatting our code, it's keeping the same code that we wrote with a for loop and an if statement and just moving it inside this memoization. We call it a memoization block. And we have source maps to preserve the source locations for this, so that all works. So then, after computing the new value, Forget saves what the inputs were, so it can compare them next time. And then it saves the output, right? It saves the filtered videos. So now imagine that we re-render, and only the heading has changed. Well, we check, have videos and filter changed? No, they haven't. So we go to the else block, and we grab the previously computed value. So the net result is just like useMemo. Right? It's the same exact behavior, just a slightly more efficient implementation. Instead of having to create a function expression, which allocates memory, not great, we can avoid that and just do a regular if statement. Instead of allocating an array for the dependencies and dynamically iterating them, we're using static JavaScript code, which can be optimized by the JavaScript engine. But Forget is actually memoizing even more. Right? This is more memoization than we thought to do. So you can see a bunch of stuff here. Let me scroll down and pick just one example. So here's the video list. So Forget is actually memoizing the JSX element itself. As long as filter videos hasn't changed, we don't recreate the element. And what this allows React to do is basically the same thing as a React.memo. So as long as filtered videos doesn't change, we'll put this exact same JSX element into our output, and when React gets to it, it sees, oh, the JSX element at this spot was exactly the same. I can skip re-rendering. Obviously, if there's a state change, it has to re-render, but in general, just like React.memo. And so this is where Forget can memoize even.
Wait, I just had to notice. T3 spotted. I think it's fair to say that React Forget's officially supporting T3.
More than a developer would typically think to do so. Okay, so let's go back over to the presentation. Pick up here, presenter view.
I wanted to see more of the code.
Those are my notes. All right, and I gotta find my place. Where was I? Okay. Yeah, okay, that's all the other stuff. All right, okay, so that's kind of looks pretty magical. Forget just figured out what to memoize. How does it actually work? So if you're not familiar with programming language theory or compiler design, this may feel pretty magical, but it's not magic, it's computer science. Forget is a low-level compiler for React. It's really specifically designed for React. And by low level, I'm referring to the fact that Forget builds a detailed, internal representation of your code. It understands the rules of JavaScript and it understands the rules of React, and it can use those to figure out what parts of your application to memoize. And these optimizations are things that are typically done by traditional compilers for languages like C++ or Rust, in addition to some novel analysis that we came up with. So that kind of together with understanding the rules of JavaScript and React, we can kind of carve out a safe space for us to apply these optimizations.
One of the main reasons React Native is so much better than any other solution is that they poured an absolute shitload of effort into making it possible by building all necessary bindings for both Android and iOS, and in the future building them for other platforms and working with other companies to do it. They positioned React Native so well that alternatives built for other languages, like I forgot the name of the Vue one, but there was a Vue React Native equivalent. It was literally just calling React Native components under the hood because it was so powerful. If they're doing what I think they're doing here and it comes out in a good enough state, I would expect to see a lot of other people copying this homework.
So by earlier this year, we'd established a solid foundation for the compiler.
Okay, so this was in 2023. So by the beginning of 2023, they had a solid idea of what the compiler would do. But it took over a year for them to get to that point from the first presentation about it. That's actually a really interesting detail to have just snagged.
And we began a series of production experiments. We used Forget on increasingly complex and high-traffic surfaces. To tell you more about that part of the story, I'll hand things over to Mo-Fei Zhang. That's right.
Hey everyone. Wow. I'm Mo-Fei Zhang.
I will say, the little bit of inside info I have on React Forget, everything I've heard is that Mo-Fei is incredible and an absolute legend. This is my first time hearing anything from her, so I'm actually really excited.
I'm an engineer on React, and I've been working on Forget since last June. It is so exciting to be here and finally be able to talk about this project. This year, we took the Forget compiler from an ambitious proof of concept to something that is now running on 2 major Meta products. That's right.
One of which is Instagram, by the way.
You can now find this project out in the wild. I mean, some folks in the audience may have already used Forget compiled apps. Our work is not quite done, but I'm so proud of how far we've come, and I'd really like to share with you our journey so far. So, about 8 months ago, we felt that Forget was finally complete enough to start shipping at Meta. We had painstakingly walked over every edge case we could find in JavaScript, and you know there's a lot of them. Our GitHub repo held over 500 tests, and each test checked that we were correctly analyzing and memoizing every permutation of valid React functions we could think of. We had really crafted this compiler with care, iterating on its design with a lot of code samples from complex Meta products. And we were finally ready for our next step, understanding how this compiler performs on real apps written by real engineers and on real devices. Does Forget actually do what it set out to do? Make any React app it touches better? Introducing our first collaborator, Quest Store, the app store for Quest VR devices. Quest Store has a large code base written in React Native. Our primary goal was to free its developers from needing to worry about menu memorization.
I don't know if it was public info that the Quest Store was in React Native until this. I'm actually not sure. So that's a detail I've known for a little bit and thought I couldn't talk about, but that's really cool that that's now out there. There's a lot of stuff in the Quest ecosystem and in VR from the Meta side that was written with React Native, and they've used it as a test bed for a ton of really cool shit. And I had no idea they were using Forget in that, and that is dope. That is so cool to hear. Shout out to all the people working on that. There's some really cool people doing cool stuff there.
While we were hopeful, we thought our chances of actually improving performance were low. Quest Store engineers had already spent a lot of time profiling and hand optimizing this app with use memo and use callback. Needless to say, we also had to move with a lot of caution when integrating Forget here. During rollout, every single test would run twice, once using Forget compiled code, once without Forget in the pipeline at all.
So in essence, the Quest Store in VR, yes, the Quest Store is a VR app you use like in virtual reality. But this is actually a really cool point that I hadn't actually thought about this before in terms of the dog fooding of React Forget. Meta's inherently going to have some of the best React developers in the world. That's just obvious that they're the creators of React and they have the core React team there to ask any questions. If anyone's going to be writing React in a performant way, it is Meta. So seeing if their compiler cannot just beat out an average React dev or a below average one like myself, rather seeing if it can beat out these really talented devs working at Meta, that's really cool. And I'm excited to see how this performs compared to their self-hand optimized code.
We also partnered with QA testers and even data scientists to check that we weren't changing product behavior. This is the product details page on Quest Store. It shows all the details of our product on the store. This page is pretty complex. As you can see, there's 5 or 6 sections that you can scroll or click through. Each section, like gallery or about, has its own complex UI logic. Forget has now been entirely rolled out on this page, meaning that every React component and hook is compiled by the Forget compiler. After enabling compilation, we thought that page interactions felt a bit more responsive. I was skeptical about this. That sounds almost too good to be true. So to understand if Forget actually helped, we used the React profiler to record the re-rendering work following a click on the left nav bar, like clicking from gallery to reviews. So this is the work done by one React render following the click before we turned on Forget. For anyone not already familiar with the React profiler, this entire diagram shows a React component tree with each individual box representing a React component. Green boxes show components that were invoked during this re-render. Gray boxes represent components that were not called. As you can see, many boxes are green here, which means that this particular re-render required a lot of work. But if you remember, from earlier, a lot of engineers had already tried to optimize this app. So the gray boxes in those subtrees that you see is what the work that they were able to save React. Now, let's take a look at the Forget compiled version to see if anything changes. As a hint, keep your eyes on the components outlined in red. Okay, Okay, ready?
Damn. That's a lot less work you have to do.
So over half of those re-rendered components kind of disappeared. This means that re-rendering now requires much less work when using compiler-optimized React. Awesome, but what was the difference? We compared existing memoization in the code base with Forget's output, and it turns out compilers can do memoization pretty well, often even better than hand-optimized code. So let's take a look at some simplified code from this page to see how. So actually, I'm going to full-size that screen. I think it's flashing, and I'm going to click through a lot of slides. Hopefully that's better. So this is some logic from an extremely stripped-down version of the media preview component on this page. It looks like a lot of code still, so let's walk through it together. Media preview receives a media object, which it renders. If the media object represents a video, we return a video card. We also have a use callback.
Don't need to go too deep in
They can
specific
just
examples.
Forget it. By the way, our compiler
I don't see what that was,
don't
though.
need to worry about making mistakes like forgetting a use callback. They can just forget it. By the way, our compiler then if benefited. We saw major improvements in interaction responsiveness for
Okay, this is what I'm
QuestScore
curious
in
about.
production.
Let's hear these numbers.
Interestingly, we also measured loading metrics like visual completion to be faster. It turns out that the initial load of this page requires multiple re-renders to initialize things like video state. By memoizing according to its fine-grained understanding of reactivity, Forget reduced the amount of work done during re-render. With Forget, re-renders completed faster. So that means we got our answer, right? Forget is done and will automatically make our React apps better all the time? Not quite. Forget's success here helped us gain a lot of confidence in its memoization strategy. But we know that fast renders are just one piece of what makes a performant UI. Fine-grained memoization is great for interactivity, but if our compiler memoizes too much, it may adversely affect other app metrics. We had a lot of ideas for how we could improve the compiled output. But first, we needed more data. Instagram.com is a React app built for the web and presents a different set of challenges from QuestStore.
Didn't
On
know that
web,
this was actually publicly confirmed already. Cool.
Memoized code translates directly to an increase in bundle size, which may in turn increase startup time. We also wanted to know if caching values created during render negatively affects memory-constrained devices, like older Android models. And of course, we hoped that Forget could make developers' lives easier. If you have visited Instagram.com in the past month, you might have used Forget. That's right, Forget is on Instagram pages like Profile, in production.
Think she was expecting applause here, and this is applause worthy. Like, building a new compiler for something as big as Instagram is pretty dope.
As you can see here. So we're already gaining an early understanding of how Forget affects metrics other than rendering speed. On the profile page, we measured less than a 1% increase in compressed code size and similar changes in retained memory. In production, we have so far seen no increase in memory-related crashes or startup time. Instead, we again saw slight improvements in visual completion.
Okay, those numbers are nuts. They saw a 1% bump in the size of the JavaScript output that's being sent to the user, and no meaningful change in memory usage or startup times. That's huge.
Just like our results from QuestStore. Oh, and there's something I forgot to mention about all of this. We used Forget to achieve these results without needing to make any changes to product code. Forget can handle almost all JavaScript syntax we actually seen in use.
That's nuts. That no product code was changed. They just ran it through the compiler and it worked. Goddamn.
It understands 95% of components on Instagram.com, and we're working to increase that even further. So what's left? The performance wins we have seen from Forget have exceeded our initial expectations. However, on the React team, we have a really high bar for releasing products. Forget is not an exception here. Our milestones are to first build a minimal proof of concept, then a version that has almost all the necessary features, carefully roll out to a small number of products, getting feedback and iterating on our design. We're at this stage now, by the way. We're working to understand Forget's impact on a pretty diverse set of real-world apps. And we're really confident about major design decisions, but might need to make further adjustments and optimizations depending on data. Our next step is to scale up until Forget is used everywhere at Meta, refining on small details. Finally, when we have stress tested and iterated enough, we release. While we still have some work ahead of us, we strongly believe that Forget will help React achieve its vision, an ergonomic developer experience paired with great performance. Thank you.
That was huge. I'm hyped. Also, the transparency here, like, it's nice that they're coming out and saying this directly. Like, we are going to do these steps, we're going to make it work internally, and then we will release it. Good to hear this officially. Let's dig in. I love that nice low res. Interesting. This is just testing with a hook. Okay. Use foo, const x is an array, x push, y is x, y push. Oh, that's a fun edge case. So it's the same array instance. You define x as let, and inputs in not change, use cached value. Yeah, nothing too surprising there. I was hoping for some more interesting how it behaves stuff there. Yeah, that was an awesome talk. Huge shout out to the team, both Joe and Mofe. You're killing it. I'm really happy with the progress on React Forget. I know this has been quite the journey to get it to this point, and I know a lot of y'all are skeptical if it'll ever happen. But if they're running it on Instagram's production code, it's closer than we think. And while it has been 2 years, I do think we're close. And 2024 might be the last year we have to write memos ourselves in React. This is a very, very exciting change. And what do you guys think about React Forget? This is a bit of a chaotic video, but there's some really cool stuff in it, and I couldn't be more hyped. I'll pin a video in the corner all about performant React code and why you shouldn't use memo if you don't need to, and whatever's below what YouTube seems to think you're gonna like. Appreciate y'all as always. I'll see you in the next one. Peace, nerds.